Imagine being able to put your body on ice and then being revived 10,000 years from now. You could wake up and find yourself in an age when science has made immortality possible. Greg Fahey may be just a few years from giving a few select people a shot at eternal life. But that can only happen if cryopreservation works on an entire human body, not just simple organs like the kidney or the bladder, but on the most complex organ of all, the brain.
This is the brain slice vitrification lab. The setup shows a hippocampal slice of the part of the brain that's associated with learning and memory in a little dish, essentially. From the right side, we have a stimulating electrode coming in, piercing the slice. On the left side, we have a recording electrode.
This brain slice has been vitrified. If it's still functional, when a pulse of electricity is fired into it, it should fire a signal back. To Greg and his team's surprise, it does. Electrical activity actually sparks up in this brain tissue, and the electrical response is every bit as strong as it was in its original state. The recovery of the brain slice complete. Preserving a slice of the brain is a crucial first step towards preserving the whole thing. It's an ambitious project that Greg is already working on.
We have found that it's fairly easy to vitrify the brain, that all of the structure seems to be preserved. But I have to say that so far, our techniques are not up to the level that we would like for that kind of speculative idea. But I couldn't say that you couldn't make up for whatever deficiencies that we have in our preservation technique today using some unknown future technology. I can't rule that out as a possibility.
One day, centuries after we say goodbye to our loved ones, our frozen bodies could be reanimated, and we'll walk the earth again. But there could be a better route to immortality, one that would change the very nature of what it means to be human. Imagine if no one ever died. Where would we all live? Our planet is already crowded enough. But maybe there's a way to live forever without all this excess baggage. Poets say the essence of us is here, but I know what really makes me me is all up here. So if I want to endure for eternity, perhaps that's all I need to hang on to. What if we could find a way to upload our brains, to digitize the very essence of ourselves? Our minds could go on living long after our flesh has died. But to make that happen, we need to understand the brain's architecture and figure out what truly makes us who we are. Olaf Sporns is a neuroscientist at Indiana University. He is attempting to unscramble the brain's tangled web.
The brain is like a big city. Cities are examples of complex systems, thousands of inhabitants and their social interactions, the flow of materials. The brain is like that. Millions of neurons, interactions between these neurons. In a sense, the brain is like a city of the mind.
The human brain is one of the most complex systems in the universe. If you stretched out all of its electrical wiring, it would extend from the Earth to the moon. Figuring out how we get from cells and wires to thoughts and memories is one of the greatest challenges known to science.
Even though we've been studying the human brain really for decades, perhaps centuries, we still don't have a complete map of how it's connected.
But Olaf is taking on this challenge. His goal is to chart every single neuron and synapse and create a complete map of the brain called the connectome.
It's a comprehensive set of connections that will allow us for the first time to understand in more detail how brain regions are connected to each other.
Olaf is creating the connectome using a leading-edge technique called diffusion imaging. It reveals the brain's long-distance connections by tracking water molecules along the neural highways. And what emerges is a detailed map of the central core of brain cell connections. Olaf thinks this is the area where our personality resides.
As we've been discovering recently, some brain regions are more connected than others. Some are more essential, perhaps, for the functioning of the brain as a whole. Those regions we call hubs.
If the brain is like a city, hubs are like major intersections where a constant flow of traffic passes through, getting people from one place to another. These intersections are so essential. If they become disrupted in any way, the whole city shuts down.
By their nature, hubs are focal points of information traffic. Information converges on these regions, and it is that ebb and flow of information and the magnitude of the information flow that really sets these hubs apart from other regions of the brain.
Olaf is getting closer to figuring out where consciousness resides. Searching for the origins of consciousness is the holy grail of neuroscience. Only when this mystery is solved can we replicate the human brain and take consciousness from a person and transfer it to a machine as a way to live for eternity. And Olaf believes he has discovered a hub that might solve this mystery: the medial parietal cortex. It's located between the brain's two hemispheres. Olaf suspects it might house the essence of who we are.
A lot of wires from the brain converge on that region. There are many lines of evidence that point to that part of the brain being really central and really important, perhaps even for awareness and consciousness.
Olaf believes he may have solved the secrets of consciousness, but there is much more work to be done before he can be sure.
I think we're getting closer to answering this question, and as we identify which parts of the brain are critical in bringing about that particular functionality, that gets us closer to answering the question, what is consciousness, and also where are the critical components of the brain that contribute to it?
Neuroscience has taken enormous steps towards mapping the brain and solving the riddle of consciousness. But will we ever be able to capture the trillions of synapses, billions of neurons, and download ourselves onto a machine?
Just imagine all the things that happen in the real world, the conversation we are having now, me producing speech sounds and gestures, our brains interacting in this embodied manner. That could not happen in a computer, and yet it is somehow the essence of what life is all about. So I'm skeptical about that.
The brain might be far too complex to immortalize, but maybe there's a simpler path to eternal life. Not for you, but for immortal beings that we create from scratch. Life on this planet has had 4 billion years to evolve. We are the latest in the long line of species. We hope we're the last. But our quest for immortality could end in disaster, because the first eternal beings may not be human, and they might just make us extinct. Complex life began from a few simple laws. The same might be true for artificial life. If humans discover those laws, there is a chance we could create living things that live forever. Oxford physicist Vlatko Vidral is trying to understand how intelligence might emerge from a system that operates on just a few basic ground rules.
So this is chess. It's a very complex game, and yet it's governed by a few very simple rules. You really have only 16 pieces on each side, and each piece can do one or two things. And you can say the same thing about life. Even though you're talking about one or two very simple rules, you still get this multitude of different possible behaviors in the universe.
In 1970, a mathematician named John Conway ran with this idea. and attempted to create artificial life forms spontaneously using a computer program. He called it the game of life.